Hello and welcome back to Mech Zone. In the previous lectures, we have already finished with the major portions and we are now left only with the cam and the gyroscope. As we all know that these two topics, that is cam and gyroscopes, were added by ISC Bangalore in GATE syllabus in the year 2016, and very simple questions have been asked from this region. Previously, this was included in the syllabus of IES and some questions were also asked in SSC JEE also. So today we shall be studying about the cams and the followers. So a cam is actually a mechanical element which is driving another element known as the follower, and in a specified way through the direct contact. So there is actually a direct contact between the cam and the follower, and since there is contact, so there must be some friction also. So here we have, this is the knife edge follower and this is the cam. The cam is rotating in the anti-clockwise sense in this particular diagram, and this follower, that is the knife edge follower, is following this cam, such that there is a point contact between the cam and the follower, and hence more wear and tear at this point is taking place. So the main topics that we have to study in this chapter is, first we will study about the classification of cams, and in the classification of cams we have the plate, radial or disc cam, and we have to remember that the line of motion of the follower and the axis of rotation of the cam are actually perpendicular to each other in the knife edge follower. And in case of the cylindrical cam, the shape of the cam would be cylindrical, and here the line of motion of the follower and the axis of rotation of the cam are actually parallel to each other. Next we come to the globoidal cam, and in the globoidal cam we are actually having the two types, that is the convex globoidal and the concave globoidal. Okay, now this is the shape of the convex globoidal and this is the shape of the concave globoidal cam. Okay, such that the line of motion of the follower is like in this direction, that means along the x direction only. Now in case of the wedge cam, we are having the wedge shaped cams, and it is moving in the positive x and negative x direction, whereas this is the follower and this is known as the roller follower. Okay, and now the second way of analysis is rise return of the cam. Rise means it will rise and then it will come to its initial position, such that the entire process is taking place between the angle 0 to 2 pi. So in the first region it is rising, then becomes maximum, and then it is returning. So on the y-axis we are having the displacement, and on the x-axis we are having the angle theta, where x is actually the follower displacement, theta is the cam rotation angle, and s is the stroke length. So stroke, this point is the stroke length. In the first portion it is rising, in the next portion it is returning. So it becomes a rise return cam. This is the second way of classification. Next is we have dwell, rise and return. In this period it is the dwell period, then it is rising, and this is the stroke length, and then it is returning. So it is the dwell, rise and return. Next is rise, dwell and return. Okay, so these are actually a way of classification of these cams. Next we have dwell, rise, dwell and return of the cam. So these are the different types of ways in which the cam can be classified. Now the next topic we come to is the important angles of the cam. We have the outstroke angle, or it is also called as the angle of ascent. Ascent means when the follower is moving out, or when the upward motion is taking place such that the follower is moving out. So it is the angle of the cam rotation in which the follower rises. The follower is actually rising in the upward direction. Next we have the return stroke angle, or the angle of descent. It is also called as the in-stroke angle, and it is the angle of cam rotation in which the follower is returning to its initial position. So in the one portion the follower is rising upward, ऊपर rise कर रहा है और फिर वो नीचे आ जाएगा. Now we come to another type of follower, that is the flat face follower. And in the flat face follower we are having actually a disc type of follower, such that if you look it from the down portion, this will be a circular disc. It is also called as the mushroom follower. Okay, mushroom follower or the flat face follower, in which the flat face or the circular disc is actually making a contact with the cam surface. Now if we look here closely, we will find that the area of contact is little bit higher as compared to the one in the knife edge follower and the roller follower. So here wearing will be slightly reduced as compared to the knife edge, but still wearing is there. Wearing तो यहाँ पर होगी ही. Side thrust यहाँ पर भी zero नहीं है, side thrust हमारा होगा, और कॉन्टैक्ट एरिया लिटिल बिट हाई है, और यहां पर क्या होता है, सरफेस स्ट्रेसेस आर एक्चुअली रिस्टोर्ड इन सच टाइप ऑफ फ्लैट फेस्ड फॉलोअर्स. Okay, next we come to the spherical face follower, in which the face or the shape of this follower is actually spherical in nature, and this is used in the IC engines. The wearing is less as compared to the knife edge. तो knife edge में हम देख रहे हैं कि अभी तक सबसे ज्यादा जो wearing है वो हमारा knife edge में ही हुआ है, और बाकी जितने भी हमारे फॉलोअर्स हैं उसमें हमारा wearing comparatively कम है. Okay, now we come to the different types of followers. The first is called as the radial follower. The next is called as the offset follower. Now in the radial follower, when the line of motion of the follower is actually passing through the center of rotation of the cam, then it is called as a radial follower. And what is offset? When the line of motion of this follower is at a certain distance from the center of rotation of the cam, then such a follower is known as the offset follower. And this distance between the line of action of this follower and the center of rotation of the cam, it is called as the offset distance. This is called as the offset distance. In some of the interviews, it has been sometime asked that what is the purpose of giving some offset to this cam. So the main purpose of giving a little bit of offset to this cam is so that we can little bit reduce the wearing, and as a result of which the side thrust is also getting reduced. The side thrust is getting reduced and the wearing is also getting reduced. So this was all about the classification of the follower, and the classification of cam we have also studied. Now we come to the important terminologies which have been used in the cam chapter. So the first is the base circle, and base circle, it is the minimum radius circle of the cam from the cam center of rotation which touches the cam profile. तो ये minimum radius का circle है which is drawn from the cam center and such that it is touching the cam profile, and the size of any cam is specified by the size of the base circle. जैसे हमारा size of the gear was decided by the diameter of the pitch circle था, वैसे यहीं पे हमारा the size of any cam is specified by the size of the base circle. Okay, now the next point is the trace point or the pitch curve. The point on the follower which is required to trace the cam profile is known as the trace point, and the curve which is traced by the trace point by keeping the cam stationary and revolving the follower around, it is known as the pitch curve. तो ये हो गया हमारा pitch curve. So next we come to the prime circle, and the prime circle is the circle which is drawn corresponding to the minimum radius circle of the pitch curve from the cam center of rotation. Okay, and next is the pressure angle. It is the angle between the line of action and the line of motion of the follower. Next we have the pitch point and the pitch circle. That point on the path pitch curve where the pressure angle is maximum is known as the pitch point. और हमारा गियर में point of engagement जब होता था तब pressure angle maximum होता था, फिर एक बार 0 हो जाता था, और फिर जब हमारा रिसेस होता था तब भी क्या हो जाता था, मैक्सिमम. तो पॉइंट ऑफ दो जगह वो मैक्सिमम होता था, एक जगह वो 0 हो जाता था. एंड द सेंटर हैविंग अ रेडियस इक्वल टू द डिस्टेंस फ्रॉम द पिच पॉइंट फ्रॉम द सेंटर ऑफ रोटेशन ऑफ द कैम इज नोन एज द पिच circle. So these were all the terminologies that will be used in the cam chapter. So this is the diagram which is showing all the circles. This is the prime circle, then pitch curve, the base circle, and we also have the pitch circle. This is the pitch point, and the line of action of the follower has been mentioned in this diagram. Now the pitch point can be more than one, but the pitch circle is only one. Pitch point एक से ज़्यादा हो सकता है, but जो pitch point है वो सिर्फ और सिर्फ pitch point एक से ज़्यादा हो सकता है, लेकिन जो pitch circle है वो सिर्फ एक ही होगा. The pressure angle exists when one body rotates the other. जब एक बॉडी दूसरी बॉडी को रोटेट करेगी तब वहां पर हमारा प्रेशर एंगल एग्जिस्ट करेगा. The pitch curve of other types for followers discussed will coincide with its base circle. ठीक है. And the trace point of the roller follower is at a point which follows the cam in full rotation. ठीक है. तो ये सब बातें हैं ये जो हमें पता होनी चाहिए. These are actually the basics about cam. एंड जो क्वेश्चन पूछे भी जाएंगे वो बहुत बेसिक ही क्वेश्चन पूछे जाएंगे. टफ क्वेश्चन कैम में नहीं पूछा जाता. Okay, so now we shall be discussing about the various important derivations which are involved in the cam chapter. For example, theta is the angle of the cam rotation, x is the follower displacement, omega is the angular velocity of cam, and s is the stroke length. Now we go for the first derivative, that is dx upon d theta, and the slope of x theta curve is actually this dx upon d theta. It represents the velocity of the follower because dx upon d theta can simply be multiplied by dx upon d theta into d theta upon dt. Okay, so this is actually constant. So first slope is actually representing the velocity of follower. Now the second derivative, that is d square x upon d theta square, it is representing the radius of curvature. So radius of curvature is actually inversely proportional to d square x upon d theta square. It is representing the acceleration of the follower. तो पहला डेरिवेटिव velocity of the follower बताएगा और second डेरिवेटिव हमें बताएगा acceleration of the follower. If any point the cam profile is sharp pointed, मान लीजिए कोई भी पॉइंट है जहां पर एक शार्प पॉइंट आ गया तो वहां पर ये रेडियस ऑफ कर्वेचर क्या हो गया, इट इज टेंडिंग टू 0. एंड इफ इट इज टेंडिंग टू 0 दैट मींस d स्क्वायर x अपॉन d थीटा स्क्वायर इज टेंडिंग टू 0. मतलब वहां पर जो एक्सेलरेशन हो गया वो हमारा अनडिफाइंड हो जाएगा, मतलब इनफाइनाइट एक्सेलरेशन हो जाएगा. और कोई भी कैम प्रोफाइल में हमारा शार्प या पॉइंटेड एंड्स नहीं होते बिकॉज इट वुड लीड टू अंडर कटिंग एंड इंटरफेरेंस फिनोमेना. सो इफ द रेडियस ऑफ कर्वेचर इज टेंडिंग टू 0 then we have the acceleration is becoming infinite for that case. And now we come to the third derivative, that is d cube x upon d theta cube, and it is representing the rate of change of radius of the curvature. So d cube x upon d theta cube, it is actually representing the jerk that I have already told you in the first lecture of theory of machines when we were discussing about kinematics and dynamics. Now we will discuss about the various derivations in the follower motion and its characteristics. Let x be the follower displacement, theta is the cam rotation, omega is the angular velocity of the cam, and we know that omega is equals to d theta upon dt. Say theta naught is the outstroke angle and t naught is the outstroke time. So we know that theta naught is equals to omega into t naught. This we have actually discussed in the IC engine when we were discussing about the time injection of the time for fuel injection. And theta r, it would simply equals to, tr, that is time for return stroke, it is equals to return stroke angle upon omega. If s is the stroke length and v is the velocity of the follower, then mean velocity would simply become s upon t naught, and t naught is theta naught upon w, so it becomes ws upon theta naught. It becomes ws upon theta naught, and mean would simply be written as mean velocity in the outstroke is theta s upon outstroke angle, and mean velocity for the return stroke is omega s upon the return stroke angle. Okay. Now the first type of motion is the uniform velocity motion, such that the displacement here is actually linear, and the v naught max and the v naught mean or v naught minimum is simply equal to omega s upon theta naught. This is during the outstroke, and during the return stroke it is omega s upon theta r. And please note that this is used in very slow speed conditions. It is used in very slow speed conditions. And we simply have to remember that it is actually having jerks equal to 8 times. We are having 8 times jerks in this velocity, that is uniform velocity motion of the cam. तो जर्क हमारा वहां पर आएगा जहां पर हमारा एक्सेलरेशन जो है वो चेंज हो जाएगा. तो नेक्स्ट वी कम टू द यूनिफॉर्म एक्सेलरेशन एंड रिटार्डेशन मोशन. And uniform acceleration and retardation motion, the displacement is actually parabolic. The velocity here is linear, and outstroke maximum velocity is 2 times the mean velocity, that is 2 omega s upon theta naught during the outstroke and 2 omega s upon theta r during the return stroke. And if we use the equation v square is equals to u square plus 2as, so u is actually 0, that is initial velocity is 0, and displacement is actually s by 2. So here the acceleration becomes 4 times omega square s upon theta naught square, and this is also used up to slow speeds. So this is the graph corresponding to the case, and here the acceleration is changing 6 times. See, this is the acceleration graph. Here it is changing 1, 2, 3, 4, 5 and 6. Since the acceleration is changing 6 times, we are having the jerks 6 times in this particular diagram. Now if we discuss about the simple harmonic motion, then when a point is moving in a circular path with uniform speed, then the motion of its reflected point on the diameter, is known as the simple harmonic मोशन. यहां पर मतलब डायमीटर पे अगर उस पॉइंट का मोशन रिफ्लेक्ट कर दे तो वो मोशन हमारा कहलाएगा सिंपल हार्मोनिक मोशन. So in case of this simple harmonic motion, we will simply only derive the formulas and we will learn the formulas by heart. So velocity is equals to pi omega s upon 2 theta naught sine pi theta upon theta naught. And acceleration is equals to dv upon dt. We will differentiate this expression with respect to time, and we will obtain a naught is equals to pi square omega square s upon 2 theta naught square cos pi theta upon theta naught. Now the third derivative would give us the jerk, and the jerk can be simply written as minus pi cube omega cube s upon 2 theta naught cube sine pi theta upon theta naught, and this is actually the maximum value in jerk. Okay, so we only have to remember these formulas, which are very important, but I am not expecting any question to come from this section, but the question can be mainly asked from the section of classification of cams and classification of followers. If it is asked for 1 mark, then theory question may come. However, for 2 marks questions, the formula needs to be remembered, because यहीं से हमारा जो है 2 marks का question बनाया जा सकता है. तो यहां पर जो था हमारा, and this system was used for medium speeds. अभी तक low speed तक ही यूज कर पा रहे थे, अब हम यहां पर medium speeds पर आ गए. और यहां पर हमारा जो जर्क है, इट इज एक्चुअली वी आर गेटिंग 4 टाइम्स, क्योंकि हमारा जो एक्सेलरेशन है वो 4 टाइम्स अपने डायरेक्शन को चेंज कर रहा है. ओके, नाउ द नेक्स्ट वी कम टू द साइक्लॉइडल मोशन. साइक्लॉइडल मींस द डिस्प्लेसमेंट ऑफ द फॉलोअर इन आउटस्ट्रोक कैन सिंपली बी गिवन बाय दिस फॉर्मूला, and v naught is dx naught upon dt or dx naught upon d theta into d theta by dt, and the d theta by dt is simply omega. So on keeping these values, we will obtain the value of v naught. So v naught simply comes out to be omega s upon theta naught 1 minus cos 2 pi theta upon theta naught, and hence we see it is a function of sine square theta. And at theta is equals to theta naught by 2, we are having the maximum value of v naught, that is 2 omega s upon theta naught. Okay, and a naught would be simply 2 pi omega square s upon theta naught square and sine 2 pi theta upon theta naught, and it is maximum at theta is equals to theta by 4 and minimum at theta is equals to 0 degree. So we have to remember these conditions, that when in case of the cycloidal profile, the acceleration is maximum or minimum at which angle. Okay, now the jerk is actually the 3 times derivative or the third derivative, and it can be evaluated as 4 pi square omega cube s theta naught cube upon cos 2 pi theta upon theta naught, and this is actually the best thing that it can be used even at high speed. So this is the diagram for this corresponding issue, and we see that here we are getting no jerks. So since we are getting no jerks, then this becomes a very favorable system to be used in different applications. Now we will discuss about some special contour cams, and in the special contour cams we first have the tangent cam with roller follower. So here the shape of the follower would be in the case of like a roller. So when the flanks of the cam are straight and tangential to its base circle and the nose circle, then the cam is known as the same. It is a symmetrical cam and works with the radial follower or radial roller follower. Let R1 is the radius of the base circle, R2 is the radius of the nose circle, R3 is the radius of the roller, L is the distance between the center of base circle and the nose circle, alpha is the angle of action, phi is the semi-angle of action of the flank. Now in these types of, especially in now portion, we will simply mainly mug up the formulas, because it has been predicted that only direct formula based questions will be asked if they are asked from this question. Okay, now the first case, when the follower is on the flank, so displacement is simply becoming R1 plus R3 into 1 minus cos theta upon cos theta. We simply have to note down these formulas and we will solve the problems, because the formulas, directly formula based questions are only asked. Now the second one is, when the follower is on the nose, then the displacement is equals to cos of phi minus alpha plus R2 plus R3 cos beta minus R1 plus R3. So only these formulas needs to be remembered, and hence X finally becomes L plus R2 minus R1 for the lift stroke. And a question has also been given, the base circle dia has been given, the roller follower 20 mm dia, the line of motion of the follower passes through the axis of the cam, the angle between the tangential face of the cam is 60 degree, the speed of the camshaft is 200 rpm and lift of the follower is 15 mm. Calculate the main dimensions of the cam, acceleration of the follower at the beginning of the lift and when the roller touches the nose and at the apex of the nose. So this is the solution corresponding to the numerical. All the data have been given. We are simply going to use the formulas and we are going to determine all the dimensions that have been asked. I am not going to explain you this numerical because this is directly a formula based numerical which has been asked, and trust me, no numerical will be asked from this portion because it is quite tough, and gate paper is made in such a way so that everybody, because the current final year students and pass out students, everybody are giving this same examination, so they are making the paper in such a balanced manner so that everybody is able to solve at least 70% or 65% of the paper. Next we come to the circular arc cam with the flank face follower. So when the flank of the cam are of convex circular arc and tangential to the base circle and the nose circle, the cam is known as the circular arc cam. It is a symmetrical cam and works with radial flat face follower. Now if we consider capital R is the radius of the circular flank, such that this is the diagram, and P is the center of the circular flank. This is the flank surface, this is the nose point, this is the line of symmetry, and this is actually the base circle of the cam. So this is now the first case is when the follower is a flank. So displacement can be simply calculated as R minus R1 1 minus cos theta, and velocity is R minus small r1 omega sine theta. So we only have to remember the formulas for displacement and velocity and acceleration also. Simply just remember these formulas, R minus R1 omega square cos theta. Next we come to when the follower is on nose. So this is the diagram for this corresponding, and displacement is simply R2 minus R1 plus L cos phi minus alpha. Okay, so this is another numerical which has been given, so I am not going to discuss this numerical because this is not at all important from the point of view of गेट और एसएससी जेई, बिकॉज इतने टफ न्यूमेरिकल्स हमसे नहीं पूछे जाते हैं जनरली, और इस पोर्शन में तो वैसे भी नहीं पूछे जाते. Okay, so with this we come to the end of the chapter on CAM. I hope that you are able to grasp at least 45% from this lecture and rest you can grasp from the book. SS रतन में कुछ चीजें आप लोग देख लीजिएगा, और वैसे तो ऑलमोस्ट मैंने जो इम्पोर्टेंट है सिर्फ उतना ही इस लेक्चर में पढ़ाया है. सो आप अपने फ्रेंड्स और कलीग्स को भी हमारे चैनल में चैनल के बारे में बताइए, सो दैट दे आर ऑल्सो able to get benefited, because everything on this channel is available absolutely for free, और सारा स्टडी मटेरियल और सारा क्वालिटी वीडियो लेक्चर्स आर ऑल्सो अवेलेबल, दैट टू एब्सोल्युटली फ्री ऑफ कॉस्ट. तो आप डेली हम लोग 4 to 5 लेक्चर्स अपडेट करते हैं, तो आप हमारे साथ रेगुलरली पढ़ते रहिए, और अपनी प्रॉब्लम्स को हमारे फेसबुक पेज पर या हमारे फेसबुक पेज पर या यूट्यूब के चैनल पे भी आप हमारे साथ शेयर कर सकते हैं, और हम लोग उसको 24 आवर्स या 48 आवर्स में हम लोग रिवर्ट बैक भी करते हैं. So thank you so much, and we are only now left with the gyroscope, which we shall be covering in the next lecture. So thank you so much for today.